One of the first decisions that we have to make in sampling is there a probability or is there not a probability? If there is, then there are certain techniques that we can use for that. If there are not, then there are other sampling techniques that we must use. We'll go through each of these individually. Probability sampling, simple random sampling. It is just that. Out of the population, I am going to randomly select observations or samples. Stratified sampling means that I'm going to break that population up into subgroups or areas based on some sort of criteria. I am then going to take the same proportion of samples randomly from each one of those groups. Systematic sampling is where I decide, as I put the population in order, how often I am going to take an observation or a sample from it. So, for example, in this picture, it looks like every fourth unit I am collecting data on. Cluster sampling is breaking the population into time groups and then taking a certain amount of observations from each of those clusters. Non-probability sampling. The snowball sampling is more of a referral-based sampling method than anything else. One thing you have to be very careful with snowball sampling is that it is very subject to biases because people are recommending the next people, and there's always bias associated with that. Judgmental sampling, you can see where the researcher chooses the sample themselves. That's certainly open to some bias as well. And then convenience sampling is where it is the most convenient or even accidental to collect data with. So, what is the proper sample size that we should be using? Well, here is a formula for continuous data, as well as a formula for discrete data. I will warn you that these sample sizes are usually suggestive in the manner of your process may not be able to provide that appropriate number for your sample size. There's always error associated with sampling. We take samples because we cannot always get the population. Therefore, we have to risk the error. The error will increase the smaller the sample size is. The larger the sample size, the lower that sampling error is. The central limit theorem is a statistical set of rules that we use for Six Sigma. You can see here that the sample means are going to be more normally distributed around a population mean. The more sample means that we get. Central limit theorem also says that the standard deviations or the spread of my data is a function as well.